Hey guys, this is a video for factoring when a is 1 using the AC method. Before we jump into factoring, there are a few things that we need to go over. First of all, we got to figure out what is standard form of a quadratic. So unit 6 is the first time we're jumping into quadratics. Now quadratics is the function where it kind of makes like a U shape, okay? So back in unit 2, we kind of learned about our parent functions. So the standard form of a quadratic is ax squared plus bx plus c. Notice how the a is attached to the x squared, b is attached to the x, and c is all by itself, and it does not have any other variables next to it. Now, a, b, and c are all numbers, okay? So you'll always have x's, but the a, b, and c will be filled in with actual numbers. So for example, let's go ahead and identify our a, b, and c here for this quadratic. X squared minus 6x plus 10. Notice that the a is always attached to the x squared. So here, if I'm to identify my a here would be 1. Okay, now remember, a, b, and c are numbers, so a is not x squared. Okay, the number in front of the x squared is a 1. They don't write it, but a is going to be 1 here. My b variable is going to be negative 6, and my c is positive 10. So it is important that you know how to identify a, b, and c of a quadratic in standard form, or else the AC method won't work. The first thing you do before you ever factor, again, factoring is the opposite of distribution. The first thing you ever do before you factor is you always check for a GCF. What's a GCF? You should have been able to go through the lesson about greatest common factor already. You always check for a greatest common factor. If you can divide something out, you need to divide it out. It makes life a lot simpler. Okay, so let's go into number 1. Now, I am going to go through this quickly, but again, this video is on YouTube, so you can rewind as much as possible. The steps are going to be exactly the same for all problems, but the number will be different. We have x squared plus 5x plus 6. Now, we're going to use the AC method with this. You can only use the AC method when you have 3 terms, okay? So, let's go ahead. The first thing you do is you check, can you take out a greatest common factor, okay? Well, if you look at all 3 of your terms, the largest number that you can divide out of everything is a 1. Does dividing by 1 change my product? No, it doesn't change my end result, correct? And then I can't divide out any x's, so my largest greatest common factor is a 1. I don't have to write that. Dividing out a 1 is pretty much useless to us, right? So you want to make sure it's in standard form. The x squared's first, the x in the middle, and the number at the end. And then you're going to go ahead and do the AC method. Okay, I'm going to go through this method fairly quickly, but I do have a PDF kind of going through a step-by-step example. So the AC method, I like to draw an X, okay? And then you put AC at the top and B at the bottom. Now, the way to remember this is that you know B stands for bottom, so you're going to put it at the bottom of your X here, okay? Now, you want to draw your X big enough so that you can write some numbers inside of it. It is called the AC method because we need to use the A and the C to help us factor this trinomial here. So, we're going to go ahead and identify A, B, and C. What is our A for this trinomial? Remember, the A is attached to the x squared. The number in front of the x squared is 1. My B here is positive 5, and my C is 6. So using the AC method, AC means I'm going to do A times C. A is 1, C is 6. 1 times 6 is 6. All right? B is going to be 5. B stands for bottom. So you put the 5 at the bottom of your x. Okay, and you're like, well, what's going to go on these sides? That's where we have to think about this. We need 2 numbers that multiply to AC, but add to B. So 2 numbers that are going to multiply to 6, but add to 5. So here's where we got to list our factors of 6. Okay, we want to think of numbers that multiply to 6, but add to 5. So 1 times 6, 2 times 3. Are those the only numbers that multiply to 6? No, because you forgot about negatives. Does it negative 1 times negative 6 also make 6? Yeah. Does it negative 2 times negative 3 make positive 6? Yeah, so you have to think about your negatives here as well. All right, so we've got to find a combination of these. Which one of these has a combination that would add up to 5? Okay, remember, we're listing out the numbers of AC. So AC in this case is 6. I want 2 numbers that are going to add to 5. I want them to add to B. And I notice that 2 plus 3 would give me 5. 1 plus 6 would give me 7, negative 1 plus negative 6 is negative 7, and negative 2 plus negative 3 is negative 5. So the only combination that works is 2 and 3. 2 times 3 is 6, 2 plus 3 is 5. So that works perfectly. So now you're going to start back at your trinomial. and you're going to go ahead and the first thing I want to mention is that your first term is always going to stay the same. The x squared stays exactly the same. The 6 stays exactly the same. Why did we do this? Well, the goal here is we're trying to split our b into two different numbers, right? We're trying to split our b here. So our b is going to split up and become 2x and 3x, and positive for both. And you're like, whoa, what just happened? Okay, again, x squared stays the same and the 6 stays the same. But you're splitting up your 5, right? So does 2x plus 3x make 5x? Yeah, $2 plus $3 makes $5. So that's what we're really doing here. Okay, the next thing you're going to do is you're going to split this into two groups. You're going to split it into two different groups. So you're going to have one group over here, you're going to have one group over here. This is called factor by grouping, but we're kind of shoving it into this lesson that we can all hit it all at once. So when you factor by grouping, make sure you bring the sign with it in the second group. You don't want to draw your line over here, so make sure you bring the sign with it. Okay, so we're factor by grouping, which is basically factoring GCFs out twice, right? So when we did a greatest common factor the previous lesson, you did it once, we're going to do it twice, basically. So here I have two terms. The largest number that goes into both terms is 1, correct? Because this is a 1. The largest thing that I can divide out of 1 is 1. So the 1 is the largest thing I can take out. What's the greatest amount of x's I can divide out? It's going to be a single x. Okay, so that single x is going to go on the outside of my parentheses. Remember, I'm taking out the greatest common factor, and then I have my leftovers on the inside. Well, x squared divided by x leaves alone with just an x. 2 divided by 1 is just positive 2. And then the x divided by x cancels. So this is what I have so far. So I've done a GCF with just the first group. Now I'm going to move on to the second group. And I forgot the plus sign on the 6. That's awkward. Go ahead and plus 6 there. Okay. Now, I'm going to do the GCF for these next two terms. Well, the largest number that goes into both terms is 3. Okay, 3 divided by 3 is the greatest I can take out, and I can take out a 3 from the 6. Can I take out any x's? No. So the largest number I can take out is a 3, and it's a positive 3. So I'm going to take out positive 3. All right. Now, here's where some people struggle, right? 3 divided by 3 is 1. So you still have what on the inside of your parentheses, right? You still have an x there, 1x, and then 6 divided by 3 is 2. Now, I want you to back out of this and then look. What do you notice about our parentheses here? They match. If they do not match, you've done something wrong. You have to go back and figure out what you did wrong. If they match, you're golden. Like, you did it. Like, it should work out perfectly. If they match, you did it great. Okay, so if they match, good job. Then we move on, okay? The two GCFs that you took out from both are going to go in their own sets of parentheses, okay? They're going to go in their own sets. And then the ones that are matching, you're going to write them right next to it just once. Okay, so the two GCFs go into their own parentheses, and the matching go into their own. And this is your simplified version. Now, how could you check your answer? Well, it's called double distributing, right? We learned double distributing back in Unit 1. So let's double distribute. X times x is x squared. X times 2 is 2x. Okay, so I've distributed one of them. 3 times x is 3x. 3 times 2 is positive 6. And then you combine your like terms. 2x and 3x make 5x. So I have x squared plus 5x plus 6. Did I end up with what I started with? Yes. So I did this correctly. So this is my final answer. I'm going to go ahead and go through the second and third example a little bit quicker. First step, check that it's in standard form. Yep. Is there a GCF other than 1? Nope. So then you move on. Now sometimes you will have a GCF, like in the third example we will have one. So then we're going to go ahead and identify A, B, and C. Now this is called factoring when A is 1. So A is typically going to be 1 in this lesson. A here is 1. B here is negative 1. So be careful. B is negative 1. And C is negative 12. Okay, AC method. A times C, 1 times negative 12 is negative 12. B is going to be negative 1. I need two numbers that multiply to negative 12 but add to negative 1. You want it to multiply to negative 12. Now, how can you remember you want it to multiply? Well, remember, A and C were being multiplied. So think about this side being the multiplication side and the B side being the addition side. So you want to multiply to negative 12 but add to negative 1. So now we're going to list out factors of negative 12. okay? So factors of negative 12 would be 1 times negative 12, negative 1 times positive 12, negative 2 times 6, 2 times negative 6, 3 times negative 4, and negative 3 times positive 4. So these are all the factors of negative 12. Now I got to figure out which one of these is going to add to negative 1. Does 1 plus negative 12 make negative 1? No. So I'm going to go through all your factors. 3 and negative 4. 3 plus negative 4 makes negative 1. So my magic numbers here are going to be 3 and negative 4. You can't just pick any numbers. They got to add to negative 1. So then we start over here. The first term stays exactly the same. The last term stays exactly the same as negative 12. But you're splitting up that middle term just like we did previously. So the negative 1x is going to change to positive 3x and negative 4x. Something I forgot to mention was that it doesn't matter the order that you put it in, you'll get the exact same answer. So if you wanted to put the negative 4 in the front and the 3x in the back, that is allowed. But again, it doesn't really matter. You'll get the same answer regardless. Okay, your parentheses order may be different, like you might have like the x plus 2 in the front, but that does not matter. Remember, multiplication, it doesn't matter the order. Okay, once we're here at this step, you can check. Does 3x minus 4x make negative 1x? Yeah. So now we're going to split it into two groups, and then you're going to do a double GCF. The largest number I can take out of both is 1, but the largest amount of x's I can take out of both is 1x. So on the outside of my parentheses, I have x squared divided by x is x, and 3x divided by x is positive 3, because these x's cancel. Okay, moving on to the next side here. The largest number I can take out of both of these is negative 4. Now, why am I all of a sudden doing negative? Well, if your first term is negative, you want to factor out a negative, and I'll show you why in a second. So if I take out a negative 4, I can't take out any x's, so that's why negative 4 is going outside by itself. Negative 4 divided by negative 4 is going to be positive 1, and I'm left with just a positive 1x. Negative 12 divided by negative 4 is positive 3. So what's the important thing to remember about this? This first term is negative in the group. Remember, in our group here, if the first term is negative, you got to divide out a negative. Now what happens if I didn't? Okay, let's try that. If I didn't divide out by negative 4 and I took out a positive 4, right? Well, then negative 4 divided by positive 4 would give me negative x. And then negative 12 divided by positive 4 would be negative 3. Do my parentheses match each other? No. You have to have them match each other. So that's what happens if we don't take out that negative 4. So it has to be negative 4. Negative 4 divided by negative 4 is positive 1. Negative 12 divided by negative 4 is positive 3. And my parentheses here indeed match. So you're going to put the GCFs together in one parentheses. And then you're going to put your matching parentheses just once right next to it. Okay, moving on to example 3. The first thing you check for is it in standard form? X squared, and then an x, and then number. So we're good. The next thing you want to look at is there a GCF? Is there a number I can factor out of all? And in this case, there is. 3x squared minus 15x minus 18. The largest number I can divide out of all of these is 3. Okay, so this one is a little bit different, right? In the previous ones, we didn't have a greatest common factor at the very beginning. Here we do. So I cannot take out any x's, but I can take out a 3. So once I take out a 3, I'm left with x squared minus 5x minus 6. All right? Now, again, we're dividing out just the 3. So we're dividing, and that's what I'm left with. And all the x's stay the same because I couldn't divide out any x's. So you're like, okay, why do we do that? Well, now, look on the inside of your parentheses and ignore that 3. Now your a is 1, and now you can factor, right? So the way I teach with my AB is, hey, let's just forget about the 3 for a second, but let's remember it at the very end. The GCF is 3, so don't make me forget that. So we're going to go ahead and move on to the AC method. A here is 1. Remember, we're not caring about that 3. That 3 is, we're ignoring it for now, okay? A is 1, B is negative 5, and C is negative 6. Now, you don't want to use the A, B, and C from the original because we did modify it a little bit. Okay, so A times C is going to be negative 6, B is negative 5. So I need to list out factors of negative 6, and so I can find the one that adds to negative 5. Now, if you know your multiplication facts, then this should be a piece of cake. But if you don't, just go ahead and list them. So negative 1 times 6, 1 times negative 6, 2 times negative 3, and negative 2 times positive 3. Those are all the factors of negative 6. And I need the one that adds to negative 5, which is going to be 1 and negative 6. Those add to make negative 5. So As earlier, the same thing. The first term stays exactly the same. The last term stays exactly the same. But the middle term is going to split and become positive 1x and minus 6x. Does 1x minus 6x make negative 5x? Yes. Does it matter the order that I put these in? No. You will get the same answer regardless. Your parentheses may be in a different order, still the same answer though. Okay, now you're going to split this into two groups and do a double GCF. Remember to bring the sign with it for the second term. Starting over here, the largest number I can divide out of both is just a 1, and then the largest amount of x's is 1x. So I can take out x, and on the inside, if I have x squared divided by x, I have x left over, and then 1 divided by 1 is just positive 1, and x divided by x is going to cancel. So I have x plus 1 on the inside of my parentheses. Over here, the largest number I can take out here is a 6. I cannot take out any x's. What do you notice about the first term in this group? It is negative, so you have to take out a negative 6. So you would have negative 6 when you take it out. And then it's negative 6 divided by negative 6 is positive 1. So I just have positive 1x on the inside. Negative 6 divided by negative 6 is positive 1. My parentheses match, so I am golden. I am great here. Now you're going to put your GCFs in their own parentheses, and you're going to put the matching ones together in its own. Now, what about that GCF at the very beginning? You're going to smack it right in the front. Just smack it right there in the front. Okay? You don't want to forget about that 3, because if you forgot about that 3, you forgot about the very first step that you just did, right? We're distributing backwards, so we're factoring, and so you want to make sure you have that 3. Okay, lastly, how would you check this problem? Well, we'll show you how to check it. Okay, checking is helpful. Okay, so to check it, the first thing we're going to do is double distribute. So I'm going to do x times x first, and I get x squared. X times 1 is positive 1x. And then I have negative 6 times x, which is negative 6x, and negative 6 times 1 is negative 6. And then I still have that 3 on the outside. But before I distribute it in, I want to go ahead and combine my like terms. X squared, this is going to be minus 5x minus 6 with a 3 on the outside, and then I'm going to go ahead and distribute, be 3x squared, negative 15x, and negative 18. Is that what I started with in the beginning? Yep. So that is factoring when a is 1.